Bioenergy engineering is a field that focuses on the production and use of bioenergy derived from biological materials. This renewable energy source is primarily generated from biomass, which includes plant materials, agricultural residues, and even waste products. Bioenergy offers a sustainable alternative to fossil fuels, and its development is crucial for reducing greenhouse gas emissions and combating climate change. As we delve deeper into bioenergy engineering, we will explore its various forms, technologies, and potential applications in today's world. One of the most common forms of bioenergy is biofuels, which are produced through the conversion of biomass into liquid fuels such as ethanol and biodiesel. Ethanol, often derived from crops such as corn or sugarcane, is widely used as a fuel additive to improve gasoline's octane rating and reduce emissions. Biodiesel, on the other hand, is made from oils found in plants and animals and can be used as a substitute for traditional diesel. By optimizing cultivation techniques and processing methods, bioenergy engineers strive to enhance the efficiency of biofuel production, ultimately making these fuels more accessible and cost-effective. Another significant application of bioenergy engineering is biogas production. Biogas is generated through the anaerobic digestion process, where microorganisms break down organic matter in the absence of oxygen. This process not only produces methane, a valuable energy source for heating and electricity generation, but also results in digestate, a nutrient-rich fertilizer that can be used to improve soil health. Bioenergy engineers are continuously looking for innovative ways to enhance biogas production efficiency, including exploring different feedstocks and optimizing reactor designs. In addition to biofuels and biogas, bioenergy engineering encompasses the burgeoning field of biomass power generation. This involves the direct combustion or conversion of biomass into electricity. Biomass power plants can utilize a variety of feedstocks, from wood chips to agricultural residues, ensuring a constant supply of renewable energy. The integration of bioenergy with existing energy grids can help stabilize electricity supply, especially on days with low wind or solar output, making it a reliable source of renewable energy. As bioenergy engineering evolves, it faces several challenges and opportunities. Ensuring sustainable feedstock supply, minimizing competition with food production, and addressing environmental impacts are key considerations for researchers and engineers in this field. However, the potential benefits are immense, as bioenergy can significantly contribute to energy independence, rural economic development, and environmental sustainability. By investing in bioenergy technologies and infrastructure, we can pave the way for a cleaner, more sustainable energy future.